more video on real numbers, chapter 1 NCERT book. It's part 3. Before watching this video, please watch part 1 and part 2. I am giving an explanation of the concept fundamental theorem of arithmetic. Next concept. First concept, Euclidean division lemma, and second concept in this chapter is fundamental theorem of arithmetic. We know all the natural numbers are either prime numbers or composite numbers. All the natural numbers are either prime numbers or composite numbers. What happens if we factorize the composite numbers? Suppose we want to factorize 102. We know how to factorize it using prime factorization method, isn't it? So, since it is an even number, we can write it as 5 2s are 10, 5 1 is 5. We can write it as, if we divide 102 by 2, we get 51. Now, 5 plus 1 is 6, means it is divisible by 3. 3 1 is 3, 3 7s are 21, means we can write 102 as 2 into 3 into 70. Okay, let us try one more. 399. Let us take 399. It is divisible by 3. It is not an even number, so it is not divisible by 2, but it is divisible by 3. So 3 1 is 3, 3 3s are 9, 3 3s are 9. Now, what about this number? Is it divisible by 3? No. Is it divisible by 7? Yes. 7 1 is 7, 63, 19. So we can write 399 as 3 into 7 into 19. If we take any composite number, we can see that it can be written as the product of prime numbers. If we take any composite number, we can write it as the product of composite numbers, or only in one way. Means we can write 102 as 2 into 3 into 17, or 3 into 2 into 17, that is same. Order doesn't matter. We can write any composite number as a product of prime numbers in a unique way. That is what is called fundamental theorem of arithmetic. Now, what is fundamental theorem of arithmetic? Fundamental theorem of arithmetic says every composite number can be factorized as the product of prime numbers in a unique way. Every composite number can be factorized as the product of prime numbers in a unique way. What are its uses? It is generally used to find out the HCF and LCM. Okay, that is its first use. Suppose we want to find the HCF and LCM of 12, 15 and 21. How can we find out? Using fundamental theorem of arithmetic. First of all, factorize 12, 15 and 21. What is 12? 12 is an even number. 2 6 are 12, 2 3s are 6. We can write it as 2 square into 3. 12 is nothing but 2 square into 3. 15 is 3 into 5, and 21 is 3 into 7. Okay, then what is the HCF of 12, 15 and 21? HCF is nothing but what is common in all the three. If two numbers are there, then what is common in that? 2. Since there are 3 numbers here, what is common in all the 3? What is common? 3 is common in all the 3 numbers. So, its HCF is equal to 3. What is the first step? Factorize it. Okay? We can write it as the product of primes. Second step, find what is common in all the 3. We get the HCF of 12, 13 and 21. HCF of 12, 13 and 21 is 3. Now, second, how to calculate the LCM? LCM is nothing but the product of greatest powers of prime numbers. Product of greatest powers of prime numbers. What are the prime factors here? 2, 3, 5, 7. We have to write the greatest powers of each prime number. Greatest powers of each prime number. What is the highest power of 2? 2 square. This 2 does not contains 2. That means this is nothing but 2 to the power 0. This is nothing but 2 to the power 0. 2 to the power 0 is 1. 1 is everywhere. So, what is the highest power of 2? 2 square. So, 2 square into, what about the highest power of 3? This is 3 to the power 1, 3 to the power 1, 3 to the power 1. Highest power is 3. Now, what is the next prime number? 5. What is the highest power of 5? 5 to the power 1. It does not contain 5, that means it is 5 raised to 0. Here also 5 raised to 0. What is the highest power? 5 itself. So, write 5. And what is the highest power of 7? Highest power of 7 is 7 itself. It does not contain 7, that means it is 7 to the power 0. Here also 7 to the power 0. So what is the highest power of 7? 7 itself. Yeah, 7 to the power 1. Hope it is clear to you. What is LCM? LCM is a product of. LCM is a product of greatest powers of prime numbers. What are the prime factors here? 2, 3, 5, 7. That means we have to write the highest powers of 2, 3, 5 and 7. Highest power of 2 is 2 square. Highest power of 3 is 3 to the power 1 or 3 itself. Highest power of 5 is 5 to the power 1 or 5 itself. And highest power of 7 is 7. There is only one 7 here, 7 to the power 1. So its greatest power is 7 itself. Now multiply all, we get 5 2s are 10, 3 2s are 6, 6 7s are 42, 420 is their LCM. 420 is their LCM. So, what is the main use of fundamental theorem of arithmetic? We can use it to find the HCF and LCM of a list of numbers. What is common in all gives the HCF, and product of highest powers of primes gives their LCM. Okay, let us practice some more questions. Find the HCF and LCM of 8, 9, 25, second, 24, 60 and 150. Okay, let us solve one by one. First question, what is the HCF and LCM of 8, 9 and 25? What is the first step? Factorize it. 8 can be written as 2 to the power 3, 2 cube. If we factorize it, we get 2 cube. 8 is nothing but 2 cube. What about 9? 9 is nothing but 3 square. What about 25? 25 is nothing but 5 square. Okay? Then what is their HCF? What is the meaning of HCF? Product of smallest powers of primes in common. What is common here? Don't say nothing. What is common? What is common? 1 is common. So what is their HCF? HCF is equal to 1. Okay. What is common? 1 is common. So what is their HCF? HCF is equal to 1. Second, what is LCM? LCM is nothing but the product of greatest powers of each prime factor. Product of greatest powers of each prime factor. What are the prime factors here? 2, 3 and 5. What is the greatest power of 2? 2 to the power 3. So 2 cube into, what is the greatest power of 3? 3 square. Here there is no 3, but that means 3 to the power 0. What is the greatest power of 3? 3 square. What is the greatest power of 5? 5 square. So, what is their LCM? LCM is equal to 2 cube into 3 square into 5 square. Let us find the final answer. Okay, 9 2s are 1800 is their LCM. Now, let us find out the HCF and LCM of 24, 60 and 150. What is the first step? Factorize it using fundamental theorem of arithmetic. So, first factorize it. 24. 24 means, it is an even number. So 12 2s are 24, 2, 6 are 12, 2, 3s are 6. So we can write it as 2 cube into 3. Okay. Now what is 60? 60. Even number. So start with 2, 2 3s are 6. Again even number. 15 2s are 30. 3 5s are 15. So we can write 60 as 2 square into 3 into 5. Okay. Now what is 150? 150 is again an even number. So 2 7s are 14, 5s are 10. 5 1 is 5, 5 5s are 25, 3 5s are 15. So we can write 150 as 2 into 3 into 5 square. First step is over. We factorized it. Now what is the next step? What is HCF? Product of smallest powers of primes. Product of smallest powers of primes. What is common in all the three? Smallest power of 2. 2 square, 2 cube. What is common? Only 2 is common. From 2 square and 2 cube, what is the smallest power of prime? 2. So what is common? 2. What about 3? The smallest power is 3. So 2 into 3. Here 5 square, here 5. It is 5 raised to 0. That is nothing but 1. So 5 is not common here. 2 is common and 3 is common. HCF is product of smallest powers of primes. That means 2 into 3 is equal to 6 is the HCF. Now LCM. What is LCM? LCM is a product of greatest powers of each prime number. So what is the product of greatest powers of each prime number? What are the prime numbers here? 2, 3 and 5. Write the greatest powers of each prime number. What is the greatest power of 2? 2 cube. 2 square, 2 cube. The greatest power is 2 cube. Into what is the greatest power of 3? That is 3 itself. What is the greatest power of 5? 5 square, 5 raised to 0. Greatest power is 5 square. So LCM is equal to 2 cube into 3 into 5 square. 2 cube means 8 into 3 into 25. 25 8s are 200. 200 into 3. 3 2s are 6. So that LCM is equal to 600. I hope it is clear to you. What is fundamental theorem of arithmetic? Fundamental theorem of arithmetic states every composite number can be factorized as the product of primes in a unique way. What is the meaning of HCF and LCM? If a set of numbers is given, how can we find the HCF? HCF is nothing but the product of smallest powers of primes, and LCM is the product of greatest powers of each prime number. Thank you for watching my video. Hope you are enjoying my classes. If you have any doubt, comment below. I will be back with more videos. Till then, bye. If you like my classes, like, share and subscribe it too. Bye.